true to this day. We're doing video number 3. Here we go. 5-9 factoring pattern for ax squared plus bx plus c when a is greater than 1. So we're going to have coefficients for this a. Let's see how this changes things. And you'll notice that it doesn't change it in any way, other than we just get bigger factors. So 1 is always place it in standard form. Is there a common factor? Now we have to be careful, right? 2, 5, and 2, no common factor. Is it a special case? No. And now we do a times c. So we're still going to do our regular. A is 2, c is 2. So that gives us factors of 4, which are 1 and 4, 2 and 2. Signs are the same. Positive means signs are the same. They're either both positive or both negative. We look here and we see that both are positive. So we go positive, 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 positive. That gives us 5. This gives us 4. Which one of those is equal to our middle? So that is our outside and inside. We're going to rewrite our trinomial into a polynomial. Plus x plus 4x plus 2. And now we're going to factor by grouping. We're going to factor out an x. We get 2x plus 1. We're going to factor out a 2, which gives us 2x plus 1. And 2x plus 1, x plus 2. Feels like the same, doesn't it? Good. And it should, because we want to make sure that we're doing the same steps, and it shouldn't be harder. Standard form, yes. Common factor, no. Special case, no. A times c. 2 and 3 make 6. Factors of 6 are 1 and 6, 2 and 3. Signs are the same, both negative. There's my negative 7. So we get 2n squared minus n minus 6n plus 3. We're going to factor out an n. We get 2n minus 1. We're going to factor out a negative 3. We get 2n minus 1. 2n minus 1, n minus 3. Signs were the same. Both were negative. It works. Outside was negative 6n. Inside was negative n, which makes negative 7n. So we can always check by multiplying those two binomials back out to see if we get the trinomial. Standard form, yes. Common factor, no. Special case, no. Special case meaning binomial square or difference of square, no, no. A times c. A is 5, c is negative 2. We get negative 10. Factors of 10 are 1 and 10, 2 and 5. Signs are different. Negative means signs are different. Meaning what? It's either going to be positive negative or negative positive. And this tells us that the bigger is going to be negative. So bigger of the two factor pairs. These are factor pairs. These are factor pairs. The bigger, 5 of 2. 5 gets a negative. 1 and 10. 10 gets a negative. That gives us negative 9 and negative 3. My middle term is negative 9. So I'm going to use these two factor pairs with those signs. So we get 5y squared plus y minus 10y minus 2. Now we're going to factor by grouping them. We have 4 terms. We're going to group them in pairs of 2. Look at the first pair, 5y squared and y. They have a common factor of y. So we get 5y plus 1. Negative 10y and negative 2. We're going to factor out a negative 2, and we get 5y plus 1. 5y plus 1 times the quantity y minus 2. Easy as that. Standard form, yes. Common factor, no. Special case, no. A times c. A is 3, c is 2, 6. 1 and 6, 2 and 3. Signs are the same. Make both positive to make 7. 3a squared plus a plus 6a plus 2. Factor out an a, you get 3a plus 1. Factor out a 2, you get 3a plus 1. 3a plus 1, a plus 2. If you can do this that fast, you are going to have a huge advantage over your peers in high school. Standard form, yes. Common factor, no. Special case, ooh, let's check it out. Binomial square, because it has 3 terms. First and third are perfect squares. So 3 terms, yes. First and third perfect squares. Perfect square, yes. Third term, positive, yes. Oh, sorry, third term positive. Yes, this is the first time we've gotten this far. Now, does the middle equal 2 times the square root of the first times the square root of the last? Our middle is 5y and 2 times the square root of the first times the square root of the last. Does that equal 2 times 2y times 1? Oh, that equals 4y. So we get 5y does not equal 4y. So that's no. So it is not a binomial square. So close. So we got to go back to a times c. That's step 4. 4 and 1. Factors of 4 and 1 are 4 and 1, 2 and 2. Signs are the same, both are negative, and those are my factor pairs. So -1 and -4. So we get 4y squared minus y minus 4y plus 1. We can factor out a y, we get 4y minus 1. Factor out a -1, and we get 4y minus 1. 4y minus 1, y minus 1. Not a binomial square. Really close. All right. Standard form, yes. Common factor, no. Special case, no. A times c. 2 times 5, 10. 1 and 10, 2 and 5. Signs are the same, both positive. Equals 11. 2a squared plus a plus 10a plus 5. Factor out an a, you get 2a plus 1. Factor out a 5, you get 2a plus 1. 2a plus 1, a plus 5. So if you've done all the problems from 5-7 and 5-8, when you get to 5-9, you're going to go, this is just as easy, because it is. And you're going to be well versed in this. Standard form, already in standard form. Common factor, no common factor. Special case, no. A times c, 5 times 2 equals 10. 1 and 10, 2 and 5, signs are the same, both are negative. This is pretty much the same problem, just with negative a, negative 10a, plus 2. Or is this the same problem that I just... No. Oh, they switched them. That's all right. That's interesting. We're going to factor out an a. We get 5a minus 1. We're going to factor out a -2. We get 5a minus 1. 5a minus 1, a minus 2. Close. Similar. Very similar. Standard form. Common factor. Special case. A times c. 7 times 2 is 14. 1 and 14, 2 and 7. Signs are the same. Both are negative. -9. 7y squared minus 2y minus 7y plus 2. Remember, these just come out, and we're just rewriting this as our outside and inside. We're going to factor out a y. We get 7y minus 2. We're going to factor out a -1, which gives us 7y minus 2. 7y minus 2, y minus 1. And the technique that many teachers, including my high school teachers, used a very, very weird method where you had a lot of It was very labor intensive. The box method is relatively labor intensive. I'd like to believe that this is probably the most efficient, and it's efficient in all of the cases. In each of the situations, when A is 1 and C is positive, when A is 1 and C is negative, when A is greater than 1 and C is positive or negative, we can just roll through this. Super fast, super easy, much more efficient. When the numbers get bigger, when the products get bigger, it's going to be just as simple. So this is really, really good. Signs are different. Bigger is negative. We get -1. Does not equal my middle. So this is prime. Okay, be aware of those primes and why they're primes and how they're created. Standard form, common factor, special case, A times C. And this method protects you against special cases, common factor, standard form. A is 12, C is 1, 1 and 12, 2 and 6, 3 and 4. Signs are the same. Both are negative. That gives me -8. 12k squared minus 2k minus 6k plus 1. We're going to factor out a 2k, 6k minus 1. We're going to factor out a -1, 6k minus 1. 6k minus 1, 2k minus 1 gives us those problems. Standard form, yes. Common factor, no. Special case, close. 4 is a perfect square, but 15 isn't. So we'll do A times C. We're going to get bigger numbers, 4 and -15. That's going to give us -60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And that's it. Signs are different. Bigger is positive, so let's go down this right column because all of my numbers on the right column are going to be bigger than the numbers on the left-hand column. We need it to equal +17. That's this pair. So we're going to have 4x squared minus 3x plus 20x minus 15. X times the quantity 4x minus 3 plus 5 times the quantity 4x minus 3. And that's going to give us 4x minus 3, x plus 5. Yeah, we can check. Outside would be 20x, inside would be -3x. That gives us +17. First are 4x squared, lasts are -15. That's just a quick check. Super easy to check also. Standard form, common factor, special case, A times C, 2 times 5 is 10. 1 and 10, 2 and 5, signs are the same, both positive. 7, 2a squared plus 2a plus 5a plus 5. Factor out of 2a, we get a plus 1. Factor out of 5, we get a plus 1. A plus 1, 2a plus 5. I mean, who can factor that fast? That is beautiful. Standard form, common factor, special case, A times C. 8 times -9, -72, 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 no, 6 and 12, 7 no, 8 yes, 8 and 9. Signs are different. Bigger is positive to make 6 right there. That makes 6. So we got 8y squared minus 6y plus 12y minus 9. Let's factor out a 2y, which gives us 4y minus 3. Let's factor out a 3, which gives us 4y minus 3. 4y minus 3 pulled out leaves us with 2y plus 3. Oh, that's a good one. That's a good one. That would be a great example of lots. The old method, you'd have all these numbers doing, and it just, this is, you know you're going to get the right answer every single time. Special case. Every single time, we know. We know if we use A times C and we break it into 4 terms, factoring group by grouping, we're always going to get the right answer every single time. It's so awesome. It's so efficient. It's so nice. Signs are different. Bigger is positive. To get me positive 3 are going to be those two. 9x squared minus 3x plus 6x minus 2. Factor out a 3x, 3x minus 1. Factor out a 2, 3x minus 1, 3x minus 1, 3x plus 2. Those are 2 fun binomials. Standard form, common factor, special case, A times C. 7 times negative 6, negative 42, 1 and 42, 2 and 21, 3 and 14, 4 no, 5 no, 6 and 7. Negative 11, that's negative 11, 7k squared plus 3k minus 11k, no, 14k, minus 14k, minus 6. We're going to factor out a k, 7k plus 3. We're going to factor out a negative 2, and that gives us 7k plus 3. 7k plus 3, k minus 2. Standard form, yes. Common factor, no. Special case, no. A times C, 4 and negative 5 is negative 20. 1 and 20, 2 and 10, 4 and 5. Signs are different. Bigger is negative. Gives me negative 8. 4u squared plus 2u minus 10u minus 5. Factor out a 2u. You get 2u plus 1. Factor out a negative 5. You get 2u plus 1. 2u plus 1 times the quantity 2u minus 5. All right, what do we got here? So standard form, no, it's not in standard form. So let's rewrite it in standard form. Number 2 is common factor. Yes, there is a common factor. There's a negative 1 that we have to factor out. We're going to factor out that negative. That gives us 2y squared plus 9y minus 10. Is it a special case? No. A times C. A is 2. C is negative 10. Negative 20. 1 and 20. 2 and 10. 3 no. 4 and 5. Signs are different. Bigger is positive. Ooh. Yeah. So this signs are different. Bigger is positive. So let's show this. That's going to give us 19. That's going to give us 8. That's going to give us 1. No middle. So this is as far as you can factor. So technically it's prime, but we could also leave this. That is factored. So that's as far as we can factor that. Standard form, nope. Let's rewrite it in standard form. Let's make sure that when we factored out the negative that I rewrote all those. Yeah, that's right. I did it right. 2 common factor. Yes, there's a negative 1 that we can factor out. Let's factor out that. Plus x minus 10. Special case, no. a times c. 3 times negative 10 is negative 30. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 yes. Signs are different. Bigger is positive. That gives me my positive 1. 3x squared minus 5x plus 6x minus 10. Factor by grouping. Let's group the first two and group the second two. So we have the opposite of, what are we going to factor out of the first two? An x, which gives us 3x minus 5. What are we going to factor out of the second two? A positive 2, which gives us 3x minus 5. So we have the negative, we have the 3x minus 5, and then we have the x plus 2. Good. Nice, efficient. We're doing it. Standard form? No. Let's rewrite it in standard form. Negative 10x squared minus x plus 3. Is there a common factor? Yes, there is. There's a negative 1 that we have to factor out because our first term cannot start with a negative. So we factor out that negative. That gives us 10x squared plus x minus 3. Notice it changed all of the terms, the signs of the terms. Negative 10x became positive 10x squared. Negative x became positive x. Positive 3 became negative 3. Now we're going to go through, continue. Is it a special case? No. Is it a binomial square or a difference of squares? No. So let's try a times c. A is 10, c is negative 3. That makes negative 30. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 and 6. The signs are different because this sign is negative. It means that the signs, the product is going to produce a negative. So our signs have to be different in order to produce a negative product. And the bigger of my outside and inside is going to be positive. So the bigger of the two factor pairs has to be positive. And now when we combine them, which one equals my middle term? 1. So that's what we're doing. And then we rewrite those factor pairs as my outside and inside. And now we're going to factor by grouping. We're going to factor out a 5x from the first two. That leaves us 2x minus 1. We're going to factor out a 3, which gives us 2x minus 1. And we get the opposite of the quantity 2x minus 1 times the quantity 5x plus 3. And I am very certain, very confident that my work is correct. Standard form? Nope. Let's rewrite it in standard form. Negative 6x squared minus 7x plus 3. Let's find the common factor. There is a common factor of a negative 1. So we have to factor out that negative. 6x squared plus 7x minus 3. It is not a special case. I'm going to try a times c, which is 6 and negative 3, which is negative 18. 1 and 18, 2 and 9, 3 and 6. Signs are different. Bigger is positive. There's my 7. And I'm looking, and I already know where this problem's going because I'm very familiar with this technique and this process, and I've done it so many times that I see where it's leading to. And I see what my answer is already going to be before. But I'm just going through the process. I'm not rushing it so fast that I can't get the answer correct, but I should be familiar with it. I should know. I should absolutely know what I'm going to do each time. I'm familiar with the process. I know I'm ahead of it. Standard form, common factor, yes. I can anticipate what it's going to do, what it's going to look like, how those solutions are going to look. Is this familiar? Is it doing what I'm expecting it to do? 2 times negative 10, negative 20, 1 and 20, 2 and 10, 4 and 5. Do I know my factor pairs inside and out? Am I so familiar with it that it comes as second nature. Ooh, wouldn't that be nice? To do math and it feel like second nature. That would be a great sign of fluency, of knowing what we're doing. I'm going to take out a 5, you get u minus 2, opposite of u minus 2, 2u plus 5. We're getting down to the last problems. Standard form, no. Rewrite it for me, please. Common factor, yes. Factor out that negative. We're going to take that negative from it. Produces 4x squared minus 8x minus 5 now. Special case, no. A times c. A is 4, 5 is negative 5 is c. Factors of 20 again. We keep doing these ones. Signs are different. Bigger is negative 8, 4x squared plus 2x minus 10x minus 5. Let's factor out a 2x. That gives us 2x plus 1. Let's factor out a negative 5. That gives us 2x plus 1. The opposite of 2x plus 1, 2x minus 5. All right. Now, what are we going to do here? Oh, we got variables. We got some variables on both sides. Doesn't change anything. Standard form, yes. Common factor, no. Special case, no. A times c. A is 1, c is negative 20. Well, this is just like the other one. That didn't make it harder. 1 and 20, 2 and 10, 4 and 5. Signs are different. Bigger is negative. Negative 1 is right there. So we get x squared plus 4xy minus 5xy minus 20y squared. This is just like section 5.8. So I don't know where this, they didn't give me an A where it wasn't. So this is kind of silly. We've already done a problem like this. 5y, x plus 4y. We get x plus 4y, x minus 5y. Okay, thank you for giving me a coefficient a that is greater. So it's in standard form. There is no common factor. It isn't a special case. We'll do a times c, which is 4 and negative 3, which is negative 12. 1 and 12, 2 and 6, 3 and 4. Signs are different. Bigger is negative. That's going to give me my negative 4. 4a squared plus 2ab minus 6ab minus 3b squared. That's a bad b. Let's factor out a 2a, which gives us 2a plus b. Let's factor out a negative 3b, which gives me 2a plus b. And we get 2a plus b, 2a minus 3b. I mean, that process is, oh, I almost thought there was a common factor. Standard form, common factor, special case, a times c, 3, negative 12, negative 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are different. Bigger is negative. Negative 5. 3a squared plus 4ab minus 9ab minus 12b squared. Factor out, just an a. 3a plus 4b. Factor out a negative 3b. You get 3a plus 4b. 3a plus 4b times the quantity a minus 3b. Did you hear me burp? That was a little burp. A baby burp. Come on now. 3 more. Standard form, common factor, special case, a times c, negative 35, 1 and 35, 5 and 7, only couple. I burped again. 5a squared minus 5ab plus 7ab minus 7b squared. Factor out of 5a. You get a minus b. Ooh, that's kind of fun. Factor out of 7b. You get a minus b. A minus b, 5a plus 7b. Standard form, common factor, special case, a times c, 2 times negative 3, negative 6, 1 and 6, 2 and 3. Signs are different. Bigger's negative. Like I said, we can already see where we're going with this. 3xy minus 3y squared. We should kind of see what my answer is going to be. Minus 3y. We can see what our answer is leading to because we're so good, because we've done so many of them. It's just like asking you times tables. You know 6 times 8, 48. You don't have to think about it because you've done it so many times. Standard form, last one. Common factor, last one. Special case, so close, but not a special case. 8 times c. 8 times negative 9 is negative 72. 1 and 72. 2 and 36. 3 and 24. 4 and 18. 5. What did I do there? 5, no. 6 and 12. 7, 8, and 9. Signs are different. Bigger's negative. I feel like we've done this one before. Positive 6 and negative 12. Y. Positive 6 yz negative 12 yz minus 9z squared. 2y, which gives us 4y plus 3z, minus 3z, which gives us 4y plus 3z. 4y plus 3z times the quantity 2y minus 3z. Yeah, nice. All right, good job. 510 is going to be fun because it is assorted ones, and we will just apply all these different techniques. We'll see binomial squares, we'll see difference of squares, we'll see common factors. There's just going to be a whole potpourri, a whole, what would they call it? What was that thing called? I don't know. Good luck, enjoy. Thanks for being here. Thanks for working hard.